Hello and welcome to a brand new unit in pre-calculus, and this is Unit 7, and this is probably one of the more important units that we'll learn in this class. And this is a section about, a unit about right triangle and circular trigonometry. So we've done right triangle trigonometry, at least in geometry, maybe perhaps algebra 2, but most likely just in geometry. So let's go ahead and get started. And we're going to use, our objectives today. We want to use Pythagorean theorem in the trigonomic functions and their inverses to solve right triangles, okay? We're also going to use special right triangle relationships to solve right triangles. So let's kind of jump in and talk about labeling sides of a right triangle, okay? So the first thing is first. Given a right triangle, the longest side over here, the one that's opposite of your right angle, is always called your hypotenuse, okay? Now, these sides over here, the other two sides, the sides that create a right angle, are called your legs, okay? And so these are your legs. And I like to refer to them as Lieutenant Dan's magic legs. Okay, so, let's kind of talk about something here. We have to determine what kind of legs we have in a right triangle. So if we look at angle A, okay, now if I look at angle A, so this is kind of the thing about labeling sides of a right triangle. If we talk about angle A, then this length is still my hypotenuse, but this length over here is opposite, okay, opposite angle A, okay? And this length over here is adjacent to angle A, okay? Now, if we were to switch this up and talk about angle B, okay, then angle B, this side over here would be the opposite of angle B. So opposite of angle B. And then this length over here would be adjacent. And adjacent means next to. Okay, so it's adjacent to angle B. All right, so it kind of depends on, what angle we're talking about, how we label the sides of a right triangle, okay? So, this length is always going to be the hypotenuse, but if we talk about this being angle A, then this length over here is opposite of angle A, okay? It doesn't touch it. And this length here is adjacent to angle A, meaning it creates that angle A with the hypotenuse, okay? And that switches when we talk about angle B, okay? Okay, so enough about that. Let's kind of go back and make sure we know our trigonometric ratios. Okay, so for angle A, all right, so I have three triangles and I have three trig functions, okay? And I'm going to do sine, cosine, and tangent trig functions for each. Okay, so when I come over here, all right, when I'm writing these out for angle A, okay, I'm going to do this. I'm going to put a little mark there for angle A, and I'm going to label, given angle A, how do I label my sides of the triangle, okay? This side is always called the hypotenuse, okay? If I have the angle A over here, then this length is my opposite side, okay? If I'm talking about this length, and with regards to angle A, this is my adjacent side, okay? So I'm going to do that for each. Okay, I'm going to come in here, write that this is my hypotenuse, this is my opposite side, this is my adjacent side, and then same thing over here, this is my angle A, this is my hypotenuse, this is my opposite side, this is my adjacent side. Okay, so now what I'm going to do is I'm going to show you guys how we write trig functions for each of these, all right? So if I were to do this, if I were to say, all right, let's first start off with sine, okay? If I took sine of angle A, let me write that right here. So sine, S-I-N, of angle A, that's going to give me my opposite side divided by my hypotenuse, okay? So I take this length and divide it by that length, and that is equal to sine of A. Okay, so it's just this ratio of side lengths, all right? Let's take a look at cosine of angle A. So if I wrote cosine of angle A, then that's going to give me my adjacent side divided by my hypotenuse. So that'd be my adjacent side divided by my hypotenuse. Okay? And the last one that we have is tangent. Okay, so if I take tangent of angle A, that's going to give me my opposite side divided by my adjacent side. So that's the opposite side divided by the adjacent side. Okay, so these are my three trig functions given angle A. Okay, now the next thing that I'm going to do is I'm going to come over here and I'm going to write these out for angle B. Okay, so for angle B, let's come over here and let's, talk about that angle. And let's label our sides of this triangle. Okay, this is going to be my hypotenuse. This is my opposite side for angle B, and then this is my adjacent side. Okay, so same thing over here. If I have angle B, then I'm going to come over here and label this as my hypotenuse. This is my adjacent side. This length is my opposite side. Okay, so then over here, this is my hypotenuse. This is my adjacent side. This is my opposite side. Okay, so, and this is all about relating it to angle B. So now let's write out our sine function. So if I said sine of angle B, okay, that's going to give me my opposite side divided by my hypotenuse. So my opposite side divided by my hypotenuse. Okay, if I did cosine of angle B, okay, cosine of angle B is equal to my adjacent side divided by my hypotenuse. Okay. And then tangent of angle B, okay, tangent of angle B is equal to the opposite side divided by the adjacent side. Okay. So you're probably wondering to yourself, how do you remember these? Okay. And so, and they're the same thing, okay? Depending on what you had over here, depending on what angle you're using, you'll get a different ratio, okay? But when I do sine, okay, in both instances, I'm taking the opposite length divided by the hypotenuse, okay? When I did cosine, I did the adjacent length divided by the length of the hypotenuse. Same thing over here, okay? And same thing with tangent. It's opposite over the adjacent side, okay? Opposite over adjacent. So how do you remember this? So one way that I remember this is I think of the, think about like there's some the letters that start here and the letters that you have here. So the way that you remember this is you think about the S, the O, and the H, okay? And so if I use sine over here, it was S, the opposite side, and then the hypotenuse, okay? And then with cosine, it was a C, an A, and an H. Okay, same thing over here, a C, an A, and an H. All right, so then same thing over here. Okay, with tangent, you had a T, you had an O, and an A. So same thing over here, T, O, and A. So you get this phrase, okay, and if I were to write those words out, for sine, you have opposite and hypotenuse. For cosine, you have the adjacent and hypotenuse. And then for tangent, you have the opposite over adjacent. So you get this phrase called so, ka, toa. Okay? And so if you remember so, ka, toa, then you can remember how to set up your ratio of side lengths. Okay? And that's all we're doing, is our ability to, take a triangle, okay, know the side lengths, take sine, cosine, or tangent of any of those angles, whether it's A or B, and you can write the ratio of side lengths, okay? So I just want to make sure that we understand how to set up so, ka, ta, given a triangle, okay? And that's all we're doing in this first part, okay? It's kind of just an introduction. All right, so let's take a look at the next one, and so this next page, and it says, determine the following trigonometric ratio. So it wants us to calculate and figure out sine of A, cosine of C, tangent of A, and tangent of C. Okay, first of all, one thing I want to highlight here with these are what goes inside this parenthesis, okay? Because sometimes that can be kind of a misconception about what that is. So when I take sine of A, C, or any of these, A or C, okay, the part that's in parentheses, okay, the part that's in parentheses, let me change my color up. My parentheses, okay, is your angle measure, okay? That's an angle measure, okay? You're taking sine of an angle A. So let's just real quick take a look at, let's highlight angle A in this picture. And so if this is angle A right here, okay, this is my hypotenuse, okay? This length from B to C is the opposite side. So I'm just going to put an O here. And then the length from A to B is the adjacent side. Adjacent means that it touches that angle, okay? So this is my adjacent side. Okay, now we also talk about angle C over here, all right, and what I want you to notice is that you still have the hypotenuse, it's still in the same position, but your opposite side and your adjacent side switch, okay? So it's important that, you kind of take a look at that and understand what those are, okay? So what I'm going to do is, let's talk about sine of A. Now, before we do anything, let's remember the phrase, so, ka, toa. Okay, so ka, and then toa. All right, so what I want to do with that is I'm going to do sine of A. Okay, so here's angle A, and I want to do sine of that. So sine is, it's the opposite side. Okay, the opposite side divided by the hypotenuse. So with angle A, my opposite side is 4, and my hypotenuse is 5. So I would write that this has a measure of 4 over 5. So 4/5. And that's what sine of A is, and that's your answer. Okay, that's all you're doing is just writing out. Okay, if I take sine of A, I'm going to take the opposite side and divide it by my hypotenuse, so that's the length of 4 over 5. So when I write sine of A, this is a number. Okay, it has the value of 4/5 in this triangle. Okay, let's take a look at cosine of C. So we're going to change angles. Look at angle C. Okay, and so that means cosine, we're going to use the adjacent side divided by the hypotenuse. So cosine of C, all right, was the adjacent side, which is 4, okay, and then divide it by the hypotenuse, which is 5. Huh, that's really interesting. So if I take sine of one angle, okay, which is the opposite side over the hypotenuse, that is equivalent for me to do cosine of C. I get the same thing. I get 4 over 5, which is kind of interesting, okay? Now, that's only going to work between sine and cosine of the opposite angles, okay? All right, let's take a look at tangent. Now, tangent, all right, we're going to do the red color. So angle A, tangent of A, gives us our opposite side over our adjacent side. So this is going to be a length of 4 divided by 3. So that's going to be 4 over 3. Okay, now if I do the same thing, tangent of angle C, that's my opposite side divided by my adjacent side. That's just going to give me 3 divided by 4. Okay, notice how you get the reciprocal when you change angles when you're doing tangent. Okay? All right, so now we're going to take this idea. So once we're able to write out these trig functions, what we're going to do is we're going to figure out how to use these ideas to find unknown side lengths in a right triangle, okay? So what I want to do is this. So I'm going to kind of show you. It says identify an angle to use, name the sides based on that angle, write an equation using a trig ratio, and then solve that equation, okay? So you can do a number of things, but let's just take a look at this. You can either use the 30-degree angle or the 60-degree angle. I'm going to use both, okay? So what I would do with this, let's use the 30-degree angle. Okay, so 30-degree angle. And what I would do is I would say, okay, looking at the 30-degree angle, all right, right here, okay, this length here is my hypotenuse. This length over here is my opposite side, okay, and this is my adjacent side. Now, I don't know what my adjacent side is, okay, but I do know what my hypotenuse is, and I'm trying to find my opposite side from 30 degrees. So this is just specific for 30-degree angles. Now what I'm going to do is I'm going to say, okay, if I'm looking for my opposite side and I'm given my hypotenuse, what trig function can I write using the opposite side and the hypotenuse? Okay, so remember, we still have to use SOHCAHTOA. Okay, so if I'm dealing with the opposite side and the hypotenuse, then I have to use my sine function. So I write this. I say sine of 30 degrees, okay, is equal to the opposite side, which is x, divided by my hypotenuse, which is 32. Okay, now what I need you guys to realize here is that when you type in sine of 30 degrees into your calculator, this is a number. Okay, so because this is a number, all right, when you type that in, it's going to give you the ratio of sides. What I have now is I can, because I have a number, that means I can multiply it, I can divide it, I can do whatever I want with it. Okay, so, you know, you can operate with sine of 30. So what I'm going to do is I'm going to rewrite this. Sine of 30 degrees, okay, is equal to x over 32. Now what I would do is if I'm trying to solve for that length x, then I can multiply both sides by 32, okay, and then I get the statement that says 32 times sine of 30 degrees, all right, is equal to that length x. Now you want to go into your calculator. Make sure that if you're dealing with degrees that you're in degree mode on your calculator, but I'm just going to type this in and see what we get. Okay, and when I plug that into my calculator, I get this. I get that this value, when I take 32 times sine of 30 degrees, I get a value of 16. So I know here that x is equal to 16. Okay, now what I'm going to do, you know, this is my answer. Okay, what I'm going to do is I'm going to show you how to do it using the 60-degree angle, because it doesn't matter which angle you use. Okay, so if I do it with the 60-degree angle, and let's kind of do that over here. All right, let me make, okay, let's do it for the 60-degree angle. All right, and so what I'm going to do is, given that 60-degree angle, okay, here, all right, this is still going to be my hypotenuse. Okay, that's not going to change. But what does change is that this is now your opposite side and this is your adjacent side. Okay, so because dealing with the 60-degree angle, okay, I know that my adjacent side is x. I'm trying to find my adjacent side and I'm given my hypotenuse. So I have to use the cosine function. So I would write this. I would say that if I'm going to do cosine of 60 degrees, okay, that's going to equal my adjacent side, which is x, divided by 32. Okay, and remember, same thing here. Cosine of 60 degrees, this is a number. So I'm going to operate like it is a number, okay? So now I can write this. I can do cosine of 60 degrees is equal to x over 32. Okay, and I'm going to do the same thing. I'm going to multiply both sides by 32, and so I can isolate my x variables, so those divide out, and I get that x, 32 times cosine of 60 is equal to x. Okay, so now let's plug that into our calculator and see what we get. Okay, and we end up getting the same thing, which is what we're supposed to get. You know, we're solving for x. X has the same value. We get that x is equal to 16. Okay, and that's the idea. Okay, so all I'm doing is I'm still following this process. I identified an angle to use. I said, okay, I'm either going to use 30 or I'm going to use 60. And I named the sides based on that angle. I set up a trig write an equation using a trig ratio, and then I solve that equation for x. Remember, these values, sine of 30 and cosine of 60, are numbers. Okay? And that's that. Okay, so now what I want to do is use trigonometric ratios to find, and it shouldn't say unknown ratios, it should say angle measures. So I'm going to come in here and cross that out and put angle measures. Okay, and so what I want to do, it says find the value of y to the nearest degree. So, you know, given angle y, all right, let's come over here and I'm going to label this triangle. So here's this angle. here's my hypotenuse, here's my opposite side, here's my adjacent side. And what I want to do is use what's called an inverse trig function. So we use inverse trig functions, okay? Functions, okay? All right, so the first thing I want to do, because you're given all three of these sides, it doesn't matter which trig function you use. Depending on what you're given, you can, evaluate these individually. So, okay, what I want to do is I want to write out sine of y degrees. I'm going to write out cosine of y degrees, and I'm going to write out tangent of y degrees. Okay, now if I write sine of y, that's my opposite side divided by my hypotenuse. So that's going to be 18 divided by 20.6. So that's going to give me 18 divided by 20.26. Okay. And then cosine of y is going to be my adjacent side divided by my hypotenuse. So it's going to be 9.3 divided by 20.26. So 9.3 divided by 20.26. And then tangent of y is my opposite side divided by my adjacent side. So 18 divided by 19.3. Okay? So we can write out these ratios, but what I want to do is use this idea to then write out to solve for y. So we've talked about this in the past, and we've talked about the concept of an inverse, where you change your input and your output. When we talk about a trig function, this is your input, your angle measure, and you get an output of a ratio of side lengths, okay? What I want to do is switch that, okay? And so we have to use an inverse function. So what I would do is this. I would say to switch this up, okay, I say that y degrees, my angle measure, is equal to sine inverse of 18 over 20.26, okay? And if I plug this part into my calculator, I will get my angle measure, all right? And I'm going to do all these separately, okay? So I'm going to do the same thing over here. I'm going to say y degrees is equal to cosine inverse of my ratio, which is 9.3 divided by 20.26. Okay, if I were to use my tangent function, I would say that y degrees is equal to tangent inverse of 18 over 9.3. This should be a 9.3, not 19.3. Okay, and so if I were to plug all of these into my calculator, okay, then I would be able to evaluate this and find my angle measure. Now remember that you need to be in degree mode, okay? So over here we need to be in degree mode. Okay, when we're finding angles with degree, we'll change that later on and we'll do what's called radian mode. But for right now we'll just do degree because we're just kind of doing a trig review. So let me plug these into the calculator and then let's see what we get. Okay, and so I've gone ahead and done these in the calculator. Now, it depends on the calculator, but sometimes a lot of calculators, like your handheld calculators, will actually have the button that has sine to the -1, cosine to the -1, tangent to the -1. And you can you just do that and plug it in how you see it. On Desmos, they use this thing called arc sine, and arc cosine, and arc tan, and they mean the same thing. Those are your inverse trig functions, okay? They just don't use that same notation, so it's a little bit different. Now, what I want you to realize here is that when I did this, we get the same thing, and that's about 62, and they wanted to do it to the nearest degree. Okay, so if we round all of these to the nearest degree, this is going to be 63 degrees, 63 degrees, and 63 degrees. So y has an angle measure of 63 degrees. Now, this one, it didn't matter which one you use because you're given all three sides, okay? But if you're just given two sides, you may have to pick a specific, value, a specific trig function to use when you're doing that, okay? Now, one of the important things in pre-calc is the study of a special right triangles, and we have two of them. And let me know if you want more practice on these, but we have two different triangles. We have a 45, 45, 90 triangle, and we have a 30, 60, 90 triangle. So in a 45, 45, 90 triangle, this is a right isosceles triangle. And what I know from this triangle is that these two legs of this triangle are congruent. Okay, if that's the case, okay, if both of these are congruent, then you'll have that these are 45-degree angles. Then I know that my hypotenuse is x, that length, the side length x, times the square root of 2, okay? Usually I use L to show that. I say L, and L root 2. But this is something that we have to memorize. We have to know it at this level, because we're going to use this quite a bit, all right, moving forward. So just so we know that. Let's talk about 30, 60, 90 triangle. And that is a triangle, and it's usually best derived from an equilateral triangle. But if I look at a 30, 60, 90 triangle, okay, so if I take an equilateral triangle and cut it in half, then I get a 30-degree angle here, a 60-degree angle here, and a 90-degree angle. Now, I know what I'll do is I will call this length here 2x. This short leg of my right triangle is going to be called x, and then the height of this triangle, this other leg of the right triangle, is going to be called x times the square root of 3, okay? Typically what I do, given a 30, 60, 90 triangle, something like this, just this little piece here, what I know is I'm going to call this length here s, this is going to be 2s, and this is going to be s times the square root of 3. Okay, and so what I know is that I have my shorter length is some number, my hypotenuse is double that length, and then my third leg is going to be that shorter leg times the square root of 3. So let's see how that applies to some problems. Okay, so we've got a couple, and we want to solve right triangles. By solving right triangles, we want to find all the angles and side lengths. So we want to find all angles, all angle measures, and side lengths. That's what it means to solve a right triangle. Okay, and so what I want to do here is, I have this triangle here. I know this is a 90-degree angle. I know this is a 60-degree angle. To find this angle, you could use a number of options. You could take 180 and subtract 90 and subtract 60, or you could know that these two angles add up to 90. Okay, and so 60 plus what gives you 90? This is going to be a 30-degree angle. Okay, so I know that. Now, given that this is a 30-degree angle, this length over here is going to be my smallest side. Okay, and so what I do is I label this as S, as 2s, and s times the square root of 3, okay? Now, in that other example on the last page, you're probably going like, hey, what are you doing? Why are we doing this? What I do is when I label this, it allows me to set up equations. It allows me to say that, I know that m is equal to s. Okay, so if I figure out what s is, I can figure out what m is, okay? And I know that n is equal to 2s, all right? So you have to think about what side lengths can I use to figure out what s is, okay? And so I know this length is 5 times the square root of 3. I also know that I've labeled this as s times the square root of 3. So what I do is I take s times the square root of 3 and set it equal to 5 times the square root of 3. Now remember, square root of 3 is a number, okay? I'm going to divide both sides by the square root of 3. All right, and when I do that, these divide out and these divide out, and I get that s is equal to 5. Okay, so therefore what I do is I take this number here, s equals 5, and I plug it in over here, and then I plug it in here. So I find out that m is equal to just 5. Okay, so this is a length of 5. All right, and then I find that n is equal to 2 times 5. Okay, which is going to give me a value of 10. All right, so this is a value of 10, and that's all I'm doing. So you don't have to use Pythagorean theorem. You can if you want, but sometimes it won't help, okay? All right, the other thing that I know over here is that I know that this angle over here is a 45-degree angle. This is a 90-degree angle. Therefore, that this other angle has to be a 45-degree angle, okay? They all have to add up to 180, all right? So I know this is a 45, 45, 90 triangle. So I know that these two lengths, those two legs are congruent. Now I'm going to label this as L, L, and then L times the square root of 2, okay? So what I know is this. I know that L is equal to 12, okay, which is pretty easy, okay? I just set those two parts equal to each other. I also know that X is equal to L, okay, which isn't not going to be that hard. And I also know that Y is equal to L times the square root of 2. So what I need to do is take this value of L, which is 12, plug it in here, and plug it in here. So I get that X is equal to 12. And that's kind of just intuitive because you know that this is congruent to this, and so it's just going to be 12. And we'll put meters for that because it has a label. And then for Y, I know that that's going to be 12 times the square root of 2 meters. Okay, and so I have an X value and a Y value, all right? And so we're done. We've solved all the sides of that right triangle, okay? All right, so now let's take a look over here. On this one, it says how to solve a right triangle, okay? Now, you're kind of given, different scenario, different, you kind of have to just think, okay? What do you have? What do you not have? What I notice here is I have two sides of a right triangle. I can find the third using Pythagorean theorem. And remember, guys, I have a friend. We'd like to say his name is Jim, but Jim doesn't reserve that much time for me, so I have to resort to my dear good friend Pythagoras, okay? So what I can do is I can set this up and I can say, all right, I know that if I take x squared, add it to 35 squared, it's going to equal 37 squared. All right, and so let's evaluate that. So 35 squared, okay, we got x squared. 35 squared is 1,225, okay? And then if I take 37 and square it, that's going to give me 1,369, okay? Now to solve for x, I'm going to subtract by 1,225 from both sides. All right, and so then I get that x squared is equal to, all right, 1,369 minus 1,225 is going to give me 144. Ooh, isn't that nice? Okay, because if I take the square root of that, I'm just going to get that x is equal to 12, okay? So I know that, all right? Now, this is 12 feet, okay? Now what I want to do is I want to set up some trig functions in order to solve for my angle measure y and the angle measure of z. All right, so what I'm going to do first is take a look at angle y, okay? Now I'm given the adjacent side and the hypotenuse here, and I also have my opposite side now, okay? So it doesn't matter which trig function you use, but because I was given already my adjacent and my hypotenuse, just to play it safe in case I got this part wrong, I'm going to use these two sides I was given. And I'm going to say, all right, if I do cosine of y, that's going to equal 35 divided by 37, okay? Now, what I want to do in order to get y by itself, I need to do an inverse, okay? So I would say that y degrees is equal to cosine inverse of 35 divided by 37, okay? And so if I plug that in the calculator, I'm going to get this. Okay, and so I end up getting that, this angle measure, and we'll just, I think it says round to the nearest degree, and so we'll just call this 19 degrees. We'll call y 19 degrees. Okay, now, so if I know that this is 19 degrees, all right, do I have to set up another trig function to solve for z? And the answer to that is no, okay? You could take 90 minus 19, so 90 minus 19 is going to give you 71 degrees. So angle z is 71 degrees. All right. You could also do a trig function to find out what z is. You could do, you could say sine, if you want to, okay, you could do sine of z is equal to 35 over 37, okay? And then you could say that z is equal to sine inverse of 35 over 37, and you could go that route. So it doesn't really matter what you do, and you'll still, if you put that in the calculator, you're still going to get 71 degrees. So guys, I know this is a very, very long video, but it's a lot of review, a lot of things that we need to make sure that we are good at before we move on. So thanks for being patient, and we'll see you soon. Thanks. Bye.